So now that you know a little bit more about how to synchronize methods, we can do a demo of what happens when we start synchronizing the cubbyhole methods. So if we go into the cubbyhole class and we hide these methods that are not thread safe, and we go in and synchronize the methods, and all I've done here is just add this synchronized keyword. And what that means is that when the producer has a lock on the put method, nobody else can use it, and when the consumer is reading the get method, nobody else can use it. And so these are now thread safe methods. And that goes part of the way to solving the issues that we saw. So if we run this, it still runs, but now we just get consumer 1 gets all of its things and producer 1 gets all of its things because it hasn't solved both problems. We have the problem of sharing the resource, but we also have the problem of notification and communication between the threads, and just making them synchronized did not solve that. So what we really need to do, beyond making them synchronized, is we also need to make it so that the threads can communicate with each other and let each other know when something's done so that it can, the other thread can take over and do things. So to do that, we take those synchronized methods and we start making use of that available instance variable in the methods. So in the get method, we say if available is equal to false, which means that there isn't something to get that hasn't already been gotten, then this thread needs to wait. And it's going to wait until available turns to true. Once the thing has been gotten, available turns to false, we print it out and we notify the rest of the threads that we're done and that they can then do their thing, return the contents. In the case of the put, it's the same thing. We say, well, if available is true, then there's already something in there that hasn't been read, so we're going to hurry up and wait. And when we come out of this wait loop, then we can set the contents, set available to true, print out the message, and notify the other threads. And so now we have both aspects of the problem solved. We have the resources synchronized through the synchronized keywords, so locks are all handled for us, and we've got this communication between the threads. When we run that, we will get producer, consumer, producer, consumer, producer, consumer, producer, consumer, producer, consumer, and it works really well. It works exactly the way we've imagined it. However, if we add another consumer to this and say, well, we'll let the consumers try and get their things. So we've put another consumer in here, and the consumers can both get the values. So what that does is it will run, and consumer 1 gets most of the things, but consumer 2 gets the 7, and consumer 2 gets the 8, consumer 2 gets the 9, but you'll notice that this program has not exited. And the program hasn't exited because neither thread has gotten to the end of their loop because they haven't managed to get 10 elements, because that is what in the cubbyhole there is a loop. No, sorry, in the consumer there is a loop where they go from 0 to 10 and they get a number. And so both of those threads are currently stuck in this loop because we have a cubbyhole that says it's not available because the producer has put in all of its numbers. So they can't get anything, and they're just sitting there waiting for something to say, oh, you can get a new number. And there isn't going to be a new number because we have too many consumers and not enough other things. And this is a problem with a lot of threads. So we have a condition here where they're starving and they don't have enough resources to get done what they wanted. They can't do the work that they're supposed to do, and so they're just stuck. They're just flailing. And there's ways to design programs around that, but you have to be aware of how that can happen first. So if we exit that one and stick to the one consumer model, then this program works perfectly well. If I was going to fix this to be able to use multiple producers and multiple consumers, I would have to have some kind of a way for the producer to say, I'm done all of the numbers that I can possibly do now, so that the consumers knew that they had to exit out of their loops. So some kind of a break in here that is based on a communication from the producer that says, I've produced all the things I'm going to, so you're not getting any more numbers. And again, I will leave that as an exercise for you.